morning, children. Today we start a new topic. Already the one textbook we have completed, that is part 1. In that we had chapters, relations, functions, then inverse trigonometric functions, matrices, determinants, derivative, differentiability, application of differentiation, all this. And now the second part is the integration. We start with the integral calculus. And if you want to have a better understanding of the integration, you must be thorough with the differentiation. Because the integration is the reverse process of differentiation. We have defined the differentiation as the limit value of that functions f of differentiations. We have defined like this: limit h tending to 0 f of x plus h minus f of x divided by h. This is what the derivative of a functions we have defined. And we have derived so lot of differentiation formulas, how to differentiate the given function, differentiation of function that by chain rule, differentiation of inverse trigonometric functions, differentiation of logarithmic function, logarithmic differentiation, and the implicit functions differentiation, parametric form of the differentiations. All these things terms we have already learned. So that means we have made thorough with the differentiation. Still, if the people are not thorough with the differentiation, I think within these 2 days you have to make it thorough. Because for understanding of the integration, we require the better concrete base of the differentiation. Because every integration things will be defined in terms of the differentiation only. And we say that the differentiation is antiderivative. So integration is antiderivative. It is antiderivative. How the definition goes then? Suppose we have a derivative of a function d by dx of a function, say it is capital Fx, some other function. Then we are thinking about a function. You are given a function like this, say f of x. A function is given to you. Think about a function whose derivative is fx. That process is called the integration. So in other way, simple way, if you say derivative of the function fx is capital Fx, then we call integral of capital Fx is fx. That means a reverse process. Derivative of the function fx is capital Fx. Then integral of this function is small fx. In simple way, we know the derivative of x squared is equal to 2x. Then we call integral of 2x is x squared. We are thinking in the reverse way. So you are given a differential functions. A given function is a differentiation of some function. We are trying to find out that function. You are given a differentiation of some functions, and we are by integration process we are finding out the that original function. I will make it clear. You are given a function which is the differentiation of some function, and by the integration process we are trying to find out that what is that some function. So it is a reverse process, and we call it as antiderivative. So in simple way, mathematically, if d by dx of fx is capital Fx, then integration of capital Fx is fx. And for d by dx derivative, this is the operation symbol, and integration we use this as a symbol. And elongated f There is some reason for using that yes also, because integration in other way it is summing up. Differentiation is cutting short. Differentiating, cutting short. That you can see from here. See, when you differentiate x cube, it becomes 3x square. When you differentiate x square, it becomes 2x. That means the power it is coming down. But in the integration process, you can see that it is going up. So that is, it is summing up. Because of that, we use the symbol as capital and log and f for the symbol. The process of integrating is called integral. The process of integrating a function is called integration. And we have different indefinite integral, because in the next topic we will be finding out the definite integral also, with putting a limit for it, within a particular limit. So that I will getting a better understanding of why the differentiation is the distinguish between the indefinite integral and definite integral. So now, first in the beginning stage, we are taking the indefinite integral as the antiderivative. Means you are given a function d by dx of fx is equal to capital Fx. Then we are trying to find out a function. You are given fx. Then integral of this function is small f. D by dx of x square is 2x. So integral of 2x is x square. So that is what the process here. Now we will be writing like this integral of fx. And to show differentiation is there with respect to a variable, d by dx differentiation with respect to x, d by dy differentiation with respect to y, d by dz differentiation with respect to z, etc. So, and this integration is connected with the differentiation. Here also we will show that with respect to what, and for that we write consider a variable under consideration is x. So if x dx will matter, that means your thing is differentiation is with respect to x. So the integration process is also with respect to x only. And here this is called this fx, this function inside the integral symbol is called the integrand. This is called integrand. And here the variable for integration is x, that is this shows, dx shows. And the entire process of doing it is called the integration. Now, so with this definition we are going ahead. So what is the definition here we are given? We are given that integration is the reverse process of the differentiation. It means d by dx of a function is equal to capital Fx. Then integral of capital Fx is equal to small f. So every formula derivation should be from the see, you know that d by dx. I just list out some formulas here. Say, you know that d by dx of x raised to n. What is n into x raised to n minus 1. So is n into x raised to n minus 1. So integral of n into x raised to n minus 1 dx will mark is x raised to n. You know that d by dx of e raised to x is equal to e raised to x. So integral of e raised to x is equal to e raised to x. And you know that d by dx of log x is equal to 1 by x. So integral of 1 by x is equal to log x. And we know that d by dx of sin x is cos x. So integral of cos x is sin x. So everywhere you can see that you require differentiation things. So you should, once you start studying the integration, it should not be confused with the process of differentiation and integration. That is why I told that you should be thorough with the differentiation process. Now one more thing just I want to mention here is, you know that d by dx of x square is 2x. d by dx of x square plus 30, it is also 2x. So as per the definition, in this case we will get integral of 2x dx will be coming as x square, and here it will be coming is x square plus 10, and here it will be coming x square plus 30. So for the same function 2x, you are getting the answer, so many answers, like an infinite number of answers there. Here x square plus 10, here x square plus 30. Same way d by dx of x square plus 100, that is also 2x. So integration answer is not unique. Infinite number of answers are there. That is the one difference here. But these answers differ by only a constant. X square plus 10, x square plus 30. So what we do is, after integrating, because what is to be written that we don't know. So after integrating by using the formula, we will be putting an f plus c, a constant, and this is called constant of integration. The reason is this one. When it is like this, you get the answer 2x, 2x, and all these things. But as per the definition of integration, as a taking as a reverse process of differentiation, you get different answers. But all these answers differ by a constant, and that is called constant of integration. So immediate after the integration process is over, using that formula, you should add a constant c, that is called constant of integration. Next things we will discuss in the next class.